Lesson 3.7, Implicit Differentiation. This is a lesson that we talked about last year, but it's a good idea to review it again. Sometimes we have relationships that cannot be written explicitly. In other words, I can't solve for y in terms of x. Let's take a look at that graph. We can see it's not even a function, but we could divide the graph into three functions. We could divide it into function 1, function 2, and function 3. But again, trying to find the explicit form for these functions will be difficult. Let's talk about differentiating implicitly. So here's an equation. Let's not try to solve for y. Let's just leave it the way it is. What we're going to do is take the derivative of both sides, treating y as a differentiable function of x. So this will be 2y dy dx, and then we're going to take the derivative of x, and that'll be 1. When we solve for dy dx, we're going to get a derivative in terms of y, not in terms of x. If we get some points, all we'll substitute is the y variable in here. And if you substitute the y variable, you'll get a slope here at 4, 2, and you'll get another slope at the point 4, negative 2. Let's take a look at a circle. Again, we could divide it into two functions, or we can treat this implicitly. So I'm going to take the derivative of both sides in terms of x. So this will be 2x plus, now this is going to require the chain rule, 2y dy dx is equal to 0. So 2y dy dx is equal to negative 2x dy dx is equal to negative x over y. So this derivative requires both the x-coordinate and the y-coordinate. We want to do it at the point 3, negative 4. So this will be negative 3 all over negative 4, which will be 3/4. So the slope at this particular point is 3/4, and you can see it looks positive. All right, I'd like you to try this problem. Stop the screencast. As soon as you're done, go ahead and take a look at the answer. The differentiation process with implicit functions are steps 1, 2, 3, and 4. Let's find the tangent and normal to the ellipse using implicit differentiation. So we're going to find the derivative of each term. So this answer will be 2x, and then this one will be x times dy dx, I'm using the product rule, plus y times dx dx, which is just 1, plus 2y, this is using this chain rule, dy dx, and then this will be 0. So this is going to be 2y minus x. It's these terms right here, this term here and this term here, and they're going to have multiplied by dy dx. And then we're going to move this term to the other side, and we're going to move this term. So this will be y minus 2x. So now our dy dx will be equal to y minus 2x all over 2y minus x. If we evaluate at the point negative 1, 2, we are going to be able to get 2 minus 2 times negative 1 all over 2 times 2 minus a negative 1, which equals 4/5. So the tangent will be y minus 2 is equal to 4/5 x plus 1. Now the normal will be perpendicular at the same point. So this will be y minus 2, and perpendicular requires the opposite reciprocal. Okay, here's a problem you can try. And shut off the screencast for a while you do it, and then you can resume after you made an effort. And here's the answer.